What is the molecular science behind EV battery degradation? Imagine a tiny world inside your electric vehicle battery, where molecules are constantly moving and interacting. Over time, these microscopic actions cause the battery to lose its ability to hold a charge. Lithium-ion batteries, which power most electric vehicles, relying on lithium ions moving between the positive and negative electrodes during charging and discharging. But with each cycle, some molecular changes happen that slowly wear down the battery's performance. One key process involves hydrogen atoms from the electrolyte, a liquid or gel that helps ions move. When lithium ions leave the cathode during charging, hydrogen atoms can stick to the cathode surface. This buildup causes the battery to lose charge even when you're not using it. It also puts stress on the cathode material, creating tiny cracks that make it less able to store lithium ions efficiently. Another factor is the physical stress from lithium ions moving in and out of the electrodes. This causes the electrode materials to expand and contract repeatedly. Over many cycles, this expansion and contraction create tiny cracks and break down the structure of the electrodes. This damage reduces the electrode's ability to hold lithium ions, which means less capacity over time. The electrolyte itself can also break down chemically. As the battery ages, the electrolyte decomposes and produces unwanted gases and solid deposits. These deposits can block the flow of ions, making it harder for the battery to work efficiently. This process increases the internal resistance, which can cause the battery to heat up more during use. On the anode side, a thin layer called the solid electrolyte interface forms from electrolyte breakdown products. This layer initially protects the anode, but as it grows thicker with continued use, it consumes lithium ions and electrolyte. This reduces the overall capacity of the battery and makes it less efficient. Heat is another big factor. When a battery heats up during use or charging, it speeds up chemical reactions that break down the electrolyte and electrode materials. This accelerated degradation means the battery's health declines faster at higher temperatures. Understanding these molecular processes helps in managing battery health better. Battery management systems monitor charge levels, temperature, and usage patterns to reduce stress on the battery. For example, avoiding full charges or discharges, limiting fast charging, and keeping the battery cool can slow down these molecular changes. Scientists are working on new materials and coatings to prevent hydrogen buildup, improve electrolyte stability, and make electrodes more resistant to cracking. These advancements could help batteries last longer, give you more miles on a single charge, and lower costs for electric vehicle owners. In short, the science behind battery degradation involves tiny molecular changes like hydrogen buildup, physical cracking from lithium cycling, electrolyte breakdown, and heat-driven reactions. Managing these factors through smart design and careful use can help keep your electric vehicle's battery healthy for many years.